Yes, hi guys, very good evening everyone. Welcome all of you once again to Om Institute and welcome to the Champion Series classes. All right, very good evening everyone and welcome to the next Champion Series class, an important one. Okay, one of the very important topics from control system, and that is the Nyquist Stability Criteria. Okay, now whether you are a student of EC or EE or instrumentation, okay, for any of the branch, this is one of the very expected topic for the GATE examination, and also the type of questions that usually coming up in from the Nyquist criteria, especially recent 5-10 years. If you see the trend, it is more about the concept and understanding of Nyquist plot, not about sketching the Nyquist plot. Okay, right. So that is why first let us in this session understand what this entire Nyquist stability criteria is. Okay, developed. Okay, about stability, the method developed about stability, relative stability of control systems. Okay, and the method introduced by very respectable Harry Nyquist. Okay, so the man himself on the screen, as you're able to see. So let's talk about what this Nyquist stability criteria is all about. You must have seen that formula n equal to p minus z. Okay, so how does that formula come into, and what type of important questions are developed from that formula? Okay, so complete detailed explanation of the Nyquist stability criteria will be taken in this session. Okay, will be taken in this session. So let's get started, guys, quickly without wasting much of the time. And you can also quickly, by the time, update your friends that the session is live. Okay, and people can keep joining, people can keep watching the session now. All right, very good evening everyone once again. Good evening, Sai, Vikas. Okay, dear, so let's get started. This is the regular introduction about me. Now, dear, before I start up, this is what, okay, randomly you see a curve here, which is the parabolic curve here, which we know we define it as y equal to x square. Now when you want to define, when you want to sketch any real function of any real variable, okay, y is a function of x. X is the independent variable, y is the dependent variable. Okay, x is the, let me just test the voice also once. This is what? Okay, randomly you see a curve here, which is the parabolic curve here, which we know we define. Yeah, it's all correct. Just a second, dear. Okay. Yeah, so y equal to x square, y is any function of x where x is known as the independent variable, y is known as the dependent variable, but both x and y are real. Okay, both the x and y are real. Okay, so let's say this is what is your x-axis and this is what is your y-axis. Okay, so to plot any y as a function of x, whether it is parabolic function or any other function, we take any one of the variables. Suppose normally independent variable, we take it on the horizontal axis, and the dependent variable we take it on the vertical axis. Okay, but today we are going to talk about Nyquist stability criteria. Stability depends on what parameter? We are going to talk about Nyquist stability criteria, and what does this stability depend upon? This stability criteria actually depends, okay, upon the roots of characteristic equation. See, stability actually depends on the poles of the closed loop transfer function. Okay, what is the closed loop transfer function? Closed loop transfer function is represented as gs upon 1 plus gshs. Okay, or poles of the closed loop transfer function are also known as the roots of the characteristic equation. What is the characteristic equation of any control system, dear? The characteristic equation of any control system is represented as 1 plus gshs equal to 0. The characteristic equation is further represented as 1 plus gshs equal to 0. Now, 1 plus gshs equal to 0, if I want to talk about the nature of roots of characteristic equation, that only will decide stability. Okay, so what is this gshs? Okay, gshs is also known as open loop transfer function. Primarily, it is function of s. It is what? It is some function of s, where s is sigma plus j omega. Okay, it is some function of s, okay, sigma plus, where s is sigma plus j omega. That means it is a function of real variable. What can I say? It is some function of the real variable, right? Just a second again. It is some function of the it is some function of the complex variable s equal to sigma plus j omega. Okay, so to talk about stability, we need to talk about characteristic equation 1 plus GSHS, out of which GSHS is a function of s. S is a complex variable. Okay, so if it is plotting any real function, okay, it's simple. Take a two-dimensional plane, take one of the axes as x, independent variable, another axis as the y, which is dependent variable. But when we talk about plotting any complex function, whether GSHS or let's take for an example z. Let's take for an example, okay, some function w, okay, which is some function of z. Okay, like I took y as a function of x. Let me define w as a function of z, where z is definitely, okay, z is definitely a complex variable. Okay, for example, again, like x square, let us define the function w equal to fz is equal to z square. Okay, take any value of z. Suppose you take z is equal to, say for example, 1 minus I. Okay, if you take z equal to 1 minus I, let me call this as first value z1. Okay, if this is z1 dear, what is the value of w1? Okay, corresponding to the z1, w1 or f of z1. Okay, that is, what is the fz function? Take the square of the given value of z. 1 minus I whole square, which is 1 plus I square minus 2I. I square is minus 1. Okay, so what is only left is minus 2I. Correct? Okay. Suppose you take z to any other value. Suppose you take it as, for example, 2 plus I. For example, 2 plus I. So what is the value of w2 or f of z2? The value of the function at z2. The role is again to take square. The function that I am discussing right now is z square. So 2 plus I whole square. 2 square. I square plus 2ab plus, that is 4I. I square again minus 1. The 4 minus 1, 3. And this is the 3 plus 4I. Correct? This is the 3 plus 4I. This is known as the 3 plus 4I. Correct, dear? Okay. Okay. So, dear, that means if you talk about z, okay, z itself is a complex variable and z itself contains, okay, two parameters, real and imaginary. The real part and the imaginary part, correct? Z itself contains the real part and the imaginary part. Z is equal to x plus iy. Okay, so definitely for any complex value, when you are taking the value of the function value is also expected to be some complex number. Okay, so w also can be some complex number. Okay, suppose of the form u plus ib. Now, first of all, to plot any complex number itself, we need an entire 2D plane because a complex number has two parts, the real part and imaginary part. To plot the value of z, what we need? Okay, to plot the value of z, what we need is something known as z plane. Okay, something known as what? Z plane. Okay, so, let's again be in z plane right now. Then we will go to the GSHS discussion. Okay, then we will go to the GSHS discussion. Okay, so what we need? Something like z plane to plot the value of z. Okay, to plot the value of the function, we need another plane because function again has two parameters, some real parameter, some imaginary parameter. Okay, we take another plane, which I will define it as fz plane. Let me take another plane and let me define it as the fz plane. Okay, keep understanding. Okay, a z plane and fz plane. Okay, both of them are complex plane. We can in general name it as complex plane, but usually complex planes are named on the name of the variable you are plotting. Here I am going to plot z. There I am going to plot fz. Okay, this is what is going to be the real axis. Okay, and this is what will be the imaginary axis. Similarly here, this is what is my real axis and this is what is my imaginary axis. Every complex plane has a real axis and imaginary axis to plot real part and imaginary part because the complex number has two parts, real and imaginary part. Now, what is the first value, dear? Z1, 1 minus I. What is the first value Z1? Come up here. Okay, what is the Z1? 1 minus I. Okay, x value 1, y value minus 1. How do you plot any complex number? By taking its real and imaginary part correspondingly. Okay, so real part 1, imaginary part, okay, minus 1, or let me call it as minus I. Okay, this corresponding point, this is known as Z1, 1 minus I. What is the Z2? 2 plus I. Okay, real part 2, imaginary part plus I. Okay, imaginary part plus I. Okay, this is some complex number which I am plotting here, Z2. Okay, because a single complex number itself needs a plane, a 2D plane known as the complex plane, known as the Z plane. That is why to draw the value, to plot the function value, we need another plane. Okay, because in a plane, if I talk about 2D plane, there is only two axes. There cannot be four axes in a 2D plane inside a plane paper. Okay, so that is why, we are actually having four values. Two values of the Z, two values of the f of Z. Okay, two values of the Z, x and y, two values of the function value, which is u and v. Okay, that is why within a single 2D plane, we cannot plot four values. That is why we take another plane. That is why we take another plane, and that is known as the FZ plane. Okay, what is that FZ plane? So first value corresponding to Z1, what is my function value? Minus 2i. What is my function value? Minus 2i. Okay, minus I minus 2i. This is my function value. Okay, corresponding to the Z2 value, what is my function value? 3 plus 4i. Okay, some real part 3 and some imaginary part 4i. Okay, this is what is the f of Z2 value. Okay, and what is this? This is what is f of Z1 value. Okay, that is what, that is what I mean by mapping from the Z plane to FZ plane. That means corresponding to this value of Z in the Z plane, corresponding to this value of Z in the Z plane, what is the value of the function in the FZ plane? Okay, is represented here. Corresponding to this value of Z, Z2 in the Z plane, what is the value of the function in the FZ plane is shown here. Okay, is shown here. Okay, okay, is shown here, right? Right? Fine. Yes, Muralidhara and Reddy, let me complete the first Nyquist stability criteria in a flow, and then please put up any of the doubts. Okay, any doubts related to this explanation, let's take right now. Okay, otherwise it will disturb the flow. It's a very beautiful, mathematical explanation of Nyquist plot, how Nyquist plot has been developed and why it is important for stability. Okay, how it can assess the stability. Okay, so what I have now shown you is whenever we need to plot any complex function fz, we need two planes. One is known as z plane, where we plot the independent variable. One is known as the fz plane, where we plot the dependent variable, where we plot the function value. Okay, again going back to the control system theory, dear. Again going to the control system theory, we know that stability depends on roots of characteristic equation, which is 1 plus GSHS equal to 0. What is GSHS? It is a function of S, and S is complex. Okay, so what is this GSHS? Okay, just like f of z, it is some function of S. It is some, function of complex variable S. That is why, like I was explaining you, mapping from Z plane to FZ plane, let us now talk about, coming back to our required control system theory, let us talk about the mapping from the S plane to the GSHS plane. Mapping from S plane to GSHS plane, because again I repeat, GSHS is a function of S. Okay, what is GSHS? GSHS is basically some function of S, some function of the complex variable. Okay, it is some function of the complex variable, right? And because it is the function of complex variable, we need two planes to plot it. One is the S plane, where I will show the S values. One is the GSHS plane. So there will be two planes in the picture, S plane and the GSHS plane, correct? The S plane and the GSHS plane. Now, okay, what is the GSHS? S minus 2, S minus 4. For example, just an example I am taking. There can be any type of function. Take a simple example. Suppose GSHS equal to S minus 2, S minus 4. Consider the values of S along a closed path. Okay, take the values of S along a closed path. Okay, in clockwise manner. Okay, you can take it in anti-clockwise also. Clockwise or anti-clockwise, anything can be taken. Okay, I have first chosen to take clockwise, then I will show you what happens if it is anti-clockwise values you take. Take the values of S in a closed path in the clockwise manner, such that 1, 0 of GSHS. Now, what are the zeros here? Okay, let us learn with zeros, then I will talk about poles also. Okay, what is GSHS? Okay, what are the zeros? Okay, S equal to 2 and S equal to 4. Clearly, na? S equal to 2 and S equal to 4 are the zeros here. Okay, because if you substitute S or equal to 2 or 4, any of the value, GSHS becomes 0. Okay, I will take the values of s along a closed path so that one of the 0 falls inside, one of the 0 falls outside. To satisfy this condition, see, everything I am doing with the reason. Why I want 1 0 inside, why I want 1 0 outside, I will explain you everything. For every reason I am doing. Why I need a closed path. Okay, what is the role of clockwise or anti-clockwise? Everything has a significance. Okay, let's learn up here. Okay, so first what I'm taking is S-plane. The values of S. Where do we take the value of S? Of course, we take the value of S in the S-plane. Okay, let us take some value of S. What are the conditions? I already told you. I want to take the values of S in a closed path in a clockwise manner. Okay, in a clockwise manner. Okay, such that 1 0 inside, 1 0 outside. Okay, where are the zeros? S equal to 2 and 4. Okay, where are the zeros? Okay. These are the two zeros of the function. One is at 2, one is at 4. Okay. So based on that, let me start suppose this is the value. Okay, this is 2 na. If this is 2, let me start with this value. Okay, suppose the value of s 2 plus 2i. Okay, then let me come here. Okay, to the next value, that is s equal to 3. Let me go to the next value. This was 2 plus 2i. Randomly I am taking the value. Okay, so next I am taking 2 minus 2i. And next let me take it as 1. Okay, let me take these values for example. Clear? Let me take these values example and let me join s. And how I am taking these values? Okay, in a clockwise manner. Okay, from the next value I come here. Okay, then I'll be moving here. And then I'll be moving here. Something like this. Okay, suppose this is S1. Suppose this is S2. Let me write it here more clearly. Suppose this is S2, which is 3. Suppose this is S3 value, third value. And suppose this is the S4 value, which is equal to how much? S4, which is 1. Okay, and see, the nature of values I have taken in a clockwise manner. Okay, so that I start the value of S from S1. I go to S2. I go to S3. I go to S4, and from S4 I go back to S1. The path taken is clockwise. Okay, such that 1 0 falls inside the closed path, 1 0 falls outside. Okay, the entire condition is met, and I'm telling you everything has a reason. Why 1 0 inside, why 1 0 outside. Okay, why clockwise, why anti-clockwise, what is the role of both, I will explain you. Okay, but yeah, as of now, what is the condition I mentioned has been satisfied. For these values of S, what is the GSHS? So GSHS is what? S minus 2, S minus 4. Let us start the calculation. Okay, let me first show you the calculation before I plot the value of GSHS. GSHS is S minus 2, S minus 4. Okay. Here. What is GSHS? Is S minus 2, S minus 4. Okay. What is the first value of S, dear? What is the first value of S? I have taken 2 plus 2i. I have taken the value as 2 plus 2i, correct? The value of S I have taken as 2 plus 2i. Okay, if this is the value of S, which is 2 plus 2i, what is GSHS? What is GS1, HS1? Okay, substitute the value now. What is the value of the function here? Okay, so that is S equal to 2 plus 2i. 2 plus 2i minus 2. 2 plus 2i minus 4. 2 and 2 cancelled. Okay, so first one is 2i and next one is minus 2 plus 2i. Solve it up, dear. 2i, 2i, 2i square. That will be real part minus 4 and this is minus 4i. Minus 4 minus 4i. Correct? That is the first value of the function. Okay, then what is the S2 value? Simple. S2 value is 3. S2 is 3. What is GS2, HS2? What is GS2, HS2? Put the S equal to 3. 3 minus 2, 3 minus 4. This is simple calculation. 1 into minus 1. So this answer is simple minus 1. Okay. Then next value S3. What is the S3 value? 2 minus 2i. 2 minus 2i. Okay. What is the GS3 HS3? What is the GS3 HS3? Okay. So S minus 2. 2 minus 2i minus 2 is 2 minus 2i minus 4. Okay. Now see the value. 2 and 2 again cancelled here. So minus 2i multiplied by minus 2 minus 2i. Calculation. Minus 2i minus 2i. 4i square, but I square minus 1. Minus 2i into minus 2. So plus 4i. Minus 4 plus 4i. Last value. Okay. Last value of S, that is S4. Okay, which is taken as how much? Which is taken as 1. Okay, this value S4 is equal to 1. Okay, so corresponding to this value, S4 equal to 1. What is the value of the function? GS4 HS4. Okay, that is S minus 2. 1 minus 2 into S minus 4. 1 minus 4. This is minus 1 into minus 3, and this is equal to 3. This is equal to how much? This is equal to the 3. Correct? Okay. These are the 4 values of S in the S plane. Corresponding to these values of S, the values of GSHS are calculated. Okay, 4 values. And now I'm going to plot these 4 values. Now I'm going to plot the 4 value. Where do we plot GSHS value, dear? We plot the value of GSHS in the GSHS plane. The first thing I told you, to plot complex functions, you need 2 plane. One is S plane, one is GSHS plane. One is S plane, one is GSHS plane. Okay, what is the first value? GS1, HS1. Okay, minus 4, minus 4i. Okay, minus 4, minus 4i. Okay, now let me plot the values. Okay, minus 4, minus 4i. Real part, minus 4. Okay, imaginary part also minus 4. You get somewhere in the third quadrant, approximately this is what? Okay, minus 4 and this is minus 4i. This is what is the first value, GS1, HS1. Correct. Then what is the next value of the function obtained? GS2, HS2, minus 1, only real. Minus 1, only real. Okay, so this is minus 1. This is the value. GS2, HS2, I will write down later. Then what is the third value obtained? GS3, HS3, minus 4 plus 4i. Minus 4 and plus 4i. This is minus 4 real part and plus 4i imaginary part. 4i. So let's say this is approximately the next value of the function, GS3, HS3. Okay, and last value, GS4, HS4 equal to 3. The GS4, HS4 equal to how much? Equal to the 3. Okay, 1, 2, 3. This is GS4, HS4. Correct. This is equal to 3. Okay, now from the first value, let me complete the plot to the second value. Okay, from the second value, I will go to the third value, GS3, HS3. From the third, I will go to the fourth, GS4, HS4. And after S4, what is the value of S? After S4, we take the value of S back as S1, closed path. The values of S are taken in closed path. So after S4, I come to S1. When I come back to S1, what is the value of the function again? GS1, HS1. What is the value of the function again? GS1, HS1. I come back to this value again. Okay. I started with this value of the function. Okay. I reached here. What is this? This is minus 1. Minus 1. This value is GS2, HS2. Okay. Then from here, I reach to GS3, HS3. From GS3, HS3, I reach to GS4, HS4. From the GS4, HS4, I reach what? I reach the GS1, HS1. Okay. This is what is the values obtained. Okay. This is what is some picture, rough picture obtained in the GSHS plane. Okay. In the GSHS plane. Clear? This is some plot obtained in the GSHS plane corresponding to what S values? Okay. For your convenience, dear, for your convenience, I will again draw the S plane picture also. Just for your convenience, let me draw the S plane picture once again. And what was the S plane picture? Okay, some value of S1 was taken. Okay, then some another value S2. Then some next value S3. Okay, then some next value here S4. And from S4 to S1. And the values of S were taken in the clockwise manner. The values of S were taken in the clockwise manner. 1, 0 inside, 1, 0 outside. Okay. Okay. Corresponding to these values of S in the S plane, the values of GSHS are plotted in the GSHS plane. Okay. Slowly, we'll link how this all calculation, okay, this plotting is related with stability. Everything will come into picture. Everything will combine. Just keep following right now. Okay. Corresponding to this value of S in the S plane, we have some values in the GSHS plane. Okay. Now, let us come back to the S plane. Okay. Let us come back to the S plane and let me write down the function under discussion. What is the function we are discussing? GSHS S minus 2, S minus 4. S minus 2, S minus 4. Okay. What is S minus 2, dear? See, when you write down any vector AB, how do you write down any vector AB? Okay, position vector of second point minus position vector of first point. So when I'm writing S minus 2, what does it mean? Okay, if I have to draw the vector describing S minus 2, okay, how is this vector written as? Okay, OB minus OA is a vector from A to B. Okay, so this should be a vector OB minus OA. This should be a vector from 2 to S. This should be a vector from 2 to S. Similarly, S minus 4 we can represent as a vector from 4 to S. Okay, from 4 to S. Right, now come up here. Okay, let me take a vector here. Okay, 2 to S. 2 is this point and S. These are the different values of S I have taken. Yeah. Suppose this is the vector 2 to S. Okay, then S can be S1, S2, S3, S4. Different values can be there. Okay. Dear, when I move along the closed path, how is this vector going to move? Please see now. Once again, let me draw this vector. Okay, and how is this vector going to move? When I take S from S1 to S2, then I go to S3, then I go to S4, then I come back to S1. Correct? What happened? How this vector moved? This vector has done a one complete revolution. One complete revolution means how much degree movement? 360 degree movement, 2 pi radians. Okay, 2 pi radians. Once again, you see, I have taken the vector from 2 to S. Okay, starting from which S? S1, going to the S2, going to the S3, going to the S4, going to the S1. Okay. So when the values of S are taken along this closed path, okay, and when you talk about the angle of S minus 2, okay, this vector S minus 2 has done one complete rotation. And one complete rotation is how much angle? 360 degree angle. One more thing. Once again, it is doing one complete rotation in what direction? How the angle is moving? It is clockwise direction, and we know that clockwise angles are negative, anti-clockwise angles are by default positive. Okay, that means when I go from, okay, for the complete closed path, okay, when I define the angle of this line S minus 2, how much is the change in the angle of this line? Okay, how much is the change in the angle of this line? This completes how much angle? This completes a 2 pi angle, but in what direction? In the clockwise direction. 2 pi clockwise actually means minus 2 pi. Okay, 2 pi clockwise actually means minus. Every clockwise angle is put with a negative sign. If you measure angle anti-clockwise, then it is said to be a positive angle. That is the rule or convention for angle, you can say. Okay. Now similarly, for the same closed path, okay, how much will be the change in the angle S minus 4? Okay, so to describe angle S minus 4, what will I do? Okay, like S minus 2 is 2 to S, S minus 4 will be a vector from 4 to S. From 4 to S. Okay, now please everybody see with concentration. This is the vector. Okay, now from S1 I go to S2. From S2 I go to S3. Okay. Then from S3 I go to S1. Sorry, S3 I go to S4. And from S4 I come back to S1. Okay. Now to describe it more clearly, let's see one calculation here. Just see one calculation with me. Okay, to understand it more clearly. Okay, this is 4 to S1. Okay, from S1, okay, let me leave it to S1. Okay, then I come to S2. And then I come to S3. Okay, these are the three pictures. Okay, from S1 I come to S2, I come to S3. So some angle has been rotated. Some angle has been rotated. What is this direction? Very carefully you see. There is some angle rotated in what direction? In the clockwise direction. Okay, sorry, in the anti-clockwise direction. This is anti-clockwise, opposite of clock. Some angle has been rotated in the anti-clockwise direction. Clear? Some angle theta has been rotated in the anti-clockwise direction. Okay, now again, I am at what point? I am at S3. Now I will go to S4. So now see in what direction now this line is moving? Clockwise. And S4 back to S1. Okay, how much is the angle now you have moved? How much from this point? Now you come back to this point. Okay. So same two lines. Now angle between the two lines is same theta, but this time you have taken a clockwise theta. This time you have taken a clockwise theta. Okay. This time I have taken a clockwise theta. Okay. So what is the change in the angle of this line? Okay. First it goes some angle theta anti-clockwise. It comes back same angle theta in the clockwise direction. Okay. It comes back same angle theta in the clockwise direction. So what is the net change in this angle, dear? What is the net change in this angle? Let me write it here. What is the net change in this angle? Okay, some theta clockwise. Okay, some theta anti-clockwise. That means it is like minus theta plus theta, and net angle is 0. Net angle is 0. Okay. The difference is the s equal to 4 is a 0. The s equal to 4 is a 0 which is outside. S equal to 2 is a 0 which is inside. Correct? S equal to 0. S equal to 2 is a 0 which is inside. Okay. Right? Now that means if I talk about this function GSHS, okay, which is s minus 2, s minus 4, which is s minus 2, s minus 4. If I talk about the angle GSHS, the phase of GSHS, the change in the angle GSHS, okay, how much will be the change in angle GSHS? First of all, let us write down the angle GSHS expression. It is equal to angle s minus 2, s minus 4, which is further equal to, whenever two complex terms are multiplied, their phase will be added, we know. In the phasor form, the phase is added to angle s minus 2 plus angle s minus 4. Okay. So how much is the change in angle GSHS? How much is the change in angle GSHS? It should be the change in angle s minus 2. Okay. Plus change in angle s minus 4. Okay. What is the change in angle s minus 2? Change in angle s minus 2, minus 2 pi. What is the change in angle s minus 4? 0. Okay. And the net change expected in GSHS is minus 2 pi. The net change expected in the angle GSHS equal to minus 2 pi. The net change expected in the angle GSHS equal to minus 2 pi, correct? Is equal to the minus 2 pi, right? Is equal to the minus 2 pi. Okay. Net change in the angle GSHS is equal to the minus 2 pi. Fine. Now, s minus 2, see, s equal to 2, okay, is a 0 which is inside. Whereas s equal to 4 describes a 0 which is outside the closed path. Okay. Which is outside the closed path. So dear, what is one point to be noted here? What is one point to be noted here? What is one point? Then I will come back to this plot. We have drawn the GSHS plot. What is one point to be noted here? Look into it. If a 0 is located inside the closed path under consideration, whatever closed path you are taking, right now I have taken this closed path randomly. Okay. If a 0 is located inside the closed path under consideration, then the change in phase of GSHS will be how much? Minus 2 pi. Okay, will be minus 2 pi. But if a 0, then we'll talk about pole. Okay, if a 0 is located outside the closed path, okay, outside the closed path, what is the change in phase of GSHS? The change in phase of GSHS is nothing, nil. What we obtained is 0. Okay, if a 0 which is located outside, okay, the change in angle is noted as 0. Okay, is noted as 0. But for a 0 which is inside, the change in phase was noted as minus 2 pi. Okay. Now suppose if GSHS was something like this. Okay. Okay. Suppose if you have a term, rather than s minus 2, you have 1 upon s minus 2. So dear, what is the angle of 1 upon s minus 2? The angle of 1 upon s minus 2, when two numbers are divided, angle will be subtracted. So 1 is a real, positive real number, 0 angle. Okay, minus of angle s minus 2. Okay, so this part is 0. Okay, so negative of the angle s minus 2. Okay, now when you write down 1 upon s minus 2, dear, s equal to 2 becomes a pole, not the 0. Because when you put s equal to 2, you have 1 upon 0, that is infinite. S equal to 2 becomes a pole. Okay. So if s equal to 2 is the pole, what is the angle 1 upon s minus 2 is negative of the angle s minus 2. That means whatever result I have written for this, okay, corresponding to the 0, Okay, if it is a pole term, there will be another minus sign coming up. So this minus minus should become plus 2 pi. This minus minus, without repeating the whole calculation, I can directly say this minus minus should become plus 2 pi. Clear? If it was a pole term. That is what the next point here. If a pole is located inside the closed path, okay, if a pole is located inside the closed path, then the change in phase of GSHS will be plus 2 pi. Okay, right. So 0 inside the closed path and the pole inside closed path. But if zeros and poles are located outside the closed path, then the change in phase is null. 0 minus 0, both are nil only. Both are nil only. Okay. These are, 2-3 points. Now before I come to fourth point, let us talk about this particular plot. Let us talk about this plot. Come up here. Come up here. What I have right now told you is change in angle GSHS is change in angle S minus 2 plus change in angle S minus 4. Change in angle S minus 2 minus 2 pi. I clearly described you by rotating that line. Okay. Change in angle S minus 4, 0. Some angle theta anti-clockwise, some angle theta clockwise. Net change was 0. Okay. Okay. So net change in angle GSHS is minus 2 pi here. Okay. Is minus 2 pi here. That is what is the basic calculations telling me. Now I have also sketched the GSHS plot. Now I have also sketched some GSHS plot. Okay. I started from which calculation? I started from GS1 HS1. Now dear, see the angle GSHS1. How do you calculate angle of any complex number? How do you calculate phase or angle of any complex number? Join that particular point with reference to the origin. Join the particular point with reference to the origin and calculate the angle with respect to the positive x-axis. Calculate the angle due to the positive real axis. If you calculate anti-clockwise, it is the positive angle. Okay, if you calculate clockwise, it is the negative angle. Both can be measured. Okay, both can be measured. Okay, if you measure the angle clockwise, just put a minus sign. Okay. Okay, so what I do is I join GSHS, the first value, GS1 HS1 with respect to the origin. Okay, now what is my next value? Now this is my starting point. How much is the change in angle? You see very clearly with me. Okay. How much? Some change here. Then GS3 HS3. Angle is changing. Okay. GS4 HS4. Finally, I come back to GS1 HS1. So see what actually happened. I come back to the same initial reference line. Okay. How much angle? If I now draw all the 4 lines, this was the first. Okay. Second. Third picture. Okay. Then I reach GS4 HS4. And finally, I reach GS1 HS1. See how much angle? Okay, some angle clockwise, then some more angle clockwise, then some more angle clockwise, some more angle clockwise. But sum of all the angle is how much? Dear, sum of all the angle is how much? It is 360 degree. Sum of all these angles is 360 degree. That is 2 pi basically. Sum of all these angles is 360 degree or 2 pi. Okay. In what direction? Very clearly, these angles are in clockwise direction. Okay, so 2 pi clockwise means minus 2 pi. So very clearly from the plot also, I am able to say what? From this plot also, from this GSHS plot, what I am able to say that, okay, what is the change in the angle GSHS? Okay. I started from the beginning and I came back to the same point. Okay, the change in angle GSHS again is 2 pi clockwise. 2 pi clockwise means minus 2 pi. Minus 2 pi. You know actually why it is minus 2 pi. Now suppose imagine if this is what, okay, if this is what is some another curve. Let me draw another GSHS random plot in front of you. Okay, dear. Just a second. Suppose, okay, assume that this is your new GSHS plot, some GSHS plane, okay, and some plot again, okay, suppose something of this kind. Okay, suppose this was point number 1. Okay, from point number 1, okay, I reach some point number 2. From point number 2, I reach some point number 3. Keep looking. From point number 3, I reach to some point number 4. From the point number 4, I reach to some point number 5. From the point number 5, I reach to some point number 6. From the point number 6, I reach to some point number 7. And from the point number 7, I again reach to point number 8, which is 1, because I have to complete the closed path. I have to complete the closed path. Okay. Now suppose if this is the GSHS plot. Okay. If suppose this is the GSHS plot. Okay. Okay. From this GSHS plot. Okay. From this GSHS plot. What is the change in angle GSHS? What is the change in angle GSHS? Observe with me, everybody. What is the change in angle GSHS? Observe. Okay, I will start from the first one. Look into this line. Okay, to calculate the angle, I join from origin. Na? So this is the angle of the first point. Now, how much will it change? So I go to the second, I go to the third, I go to the fourth. Okay, while I am coming back, see, while I am going to the fifth, in between one 360-degree complete, because I started from this point, right? Okay, so now more than 360. Now I go to the point number 6. Now I go to the point number 7. I come back to point number 8, which is colliding at 1. Okay, again same point. Okay, but after 2 rotations, that means how much change in the angle? Okay, 2 times 360 degree. How much it is? It is equal to 2 times 360 or 2 times 2 pi, and both the time in the clockwise direction. Both the time in the clockwise direction. That means this is equal to minus 4 pi clockwise. This is minus 4 pi. Clockwise means minus. You know now point is why it is minus 4 pi. Why the earlier one is minus 2 pi. Okay. Because look into it. If I talk about the earlier plot, this is the path from first back to the first. Actually, the earlier plot is enclosing the origin. Okay, it is encircling the origin once. Okay, it is encircling the origin once. But if you look into the second plot, see, 1, 2, 3, 4. Okay, 1, 2, 3, 4. Okay, then 5, 6, 7, 8. How many times it is encircling the origin? It is encircling the origin. How many rotations it is making around origin? 2 times. How many times it encircles the origin means how many times it is moving around the origin? 2 times. Okay. So this minus 4 pi, dear, let me again write it as, okay, minus 2 pi, or let me call it as 2 pi into minus 2. Why this is 2? Because there are 2 encirclements. Because there are 2 encirclements of what? Of the origin. There are 2 circlements of the origin. There are 2 circlements of the origin by the GSHS plot. Okay, in what direction? Both the encirclements are in the clockwise direction. Both the encirclements are in the clockwise direction. That is why minus sign is coming. Previous one is minus 2 pi. Let me again write it as minus 2 pi into minus 1. Why this 1? Because there is one encirclement of the origin. How many times you move around origin, that is actually mattering here. So there is one encirclement of the origin. Okay, there is one encirclement of the origin by the GSHS plot. And that one encirclement is again in what direction? In the clockwise sense. In the clockwise sense. So the minus signs. Okay, so the minus sign. So the minus sign. So now suppose dear, if there is a GSHS plot. Now suppose dear, if there is a GSHS plot, like this example, okay, or this random example, any GSHS plot, suppose it is moving around origin n times, it is encircling the origin n times. Okay, if a GSHS plot encircles the origin n times, okay, encircles the origin n times, okay, in anti-clockwise sense, I'll take positive. If clockwise, it will become negative. So if GSHS plot encircles the origin n times, then what is the angle GSHS, or what is the change in the angle GSHS then? Okay, change in angle GSHS will be 2 pi into n. Okay, 2 pi into n, where n, if you take anti-clockwise, then only it is plus. N can be minus also if you take clockwise encirclement. Like previous examples, it is 2 pi into minus 2. Why minus 2? Because two clockwise encirclements. Correct, dear? Because two clockwise encirclements. Okay. So change in angle GSHS is equal to 2 pi into N. Coming back to the previous three. Previously what I told you, if there is a 0 inside the closed path, change in phase minus 2 pi. If there is a pole inside the closed path, change in phase of GSHS 2 pi. If pole and 0 are outside, then change in phase of GSHS nothing, no contribution. That means if GSHS has p poles and z zeros inside the closed path, if GSHS suppose has p poles and z zeros inside the closed path, then what is the change in phase of GSHS? Okay, for every pole inside the closed path plus 2 pi. So if there are p poles, it is plus 2 pi into p. Okay, if there are z zeros, so minus 2 pi into z. If there are z zeros, so minus 2 pi into z. Okay, minus 2 pi into z. Correct? Right. So that is why 2 pi into p and minus 2 pi into z. So total change is 2 pi common p minus z. Okay. So what I'm relating now, if the GSHS has p poles and z zeros, which poles and zeros? Inside the closed path, because outside zeros do not matter. Okay. Right. So if GSHS has p poles and z zeros inside, then the change in phase GSHS is 2 pi p minus z. Then another way I'm saying that, suppose you draw the GSHS plot, something like this or something like this, and on drawing the GSHS plot, you notice that GSHS encircles the origin n times. It is moving around origin n times. Then the change in angle GSHS is 2 pi n, where n will be plus for anti-clockwise, minus for clockwise. So if I compare both of them, 2 pi n is 2 pi p minus z. Okay, 2 pi cancel. 2 pi cancel, n is equal to p minus z. 2 pi cancel, n is equal to p minus z. But let me mention that in the very beginning, what are the values of s taken? The values of s taken in the closed path are also in the clockwise manner. If you reverse this, the result will reverse. That means I'll write down the conclusion something like this. Okay, so the closed path, okay, in the S-plane, was taken in the clockwise sense. Okay, and hence we have got the result n equal to p minus z. N is equal to the p minus z. If you take the closed path in the S-plane, in the anti-clockwise sense, then you know the result will be just obtained as reverse. N will be then obtained as the z minus p. Correct. N will be then obtained as the z minus p. Okay. Now, sometimes not only on stability, there can be a question only on this particular concept. See this GATE 21 mark question. Read this question. Okay, just read this question. Yes, guys. Okay. Yeah, so Sai Vikas says option number C. Let's continue this. The pole zero map of a rational transfer function GS is shown below. Okay. When the closed contour tau is mapped into the GS plane. When the closed contour tau is mapped into the GS plane. So see, this is what? The pole zero map is given. Okay. Okay. So some function GS, some pole zero plot is given. Okay. When the closed contour tau, this is some closed contour tau mentioned. Have a look into it. Okay. This is some closed contour tau. When it is mapped into the GS plane, then the mapping in the GS plane encircles origin how many times? Okay, see, this question is also talking about the encirclement of -1 plus j0. Very soon I will come to it. The encirclement of -1 plus j0, very soon I will come to it. Okay, just skip it for a moment. But right now let's talk about origin point. Okay, what I have taught you till now? What I have taught you till now? Okay, see, the closed path. Okay, this is the closed path. This is the S-plane picture. Okay, this is the S-plane picture. Okay, there is some S-plane picture given to you containing some pole zero of GS, and this is the closed path. Okay, in what direction? It is very clearly given in the clockwise direction. Clear, everyone? See na, it is given in the clockwise direction. Okay, because it is in clockwise sense, what is the formula to be taken? N equal to P minus Z, because I told you clockwise sense mean P minus Z. If the closed path is given as anti-clockwise closed path, then Z minus P is the formula. So right now P minus Z. Right now P minus Z. Okay. Now dear, if this is P minus Z, if this is P minus Z, what is the value of N? Which P and Z, dear? Very clearly, which P and Z comes in the formula? P and Z are not the total poles and zeros of GS. It is the poles and zeros which are inside. Okay, so how many poles are inside? Have a look into it. Okay, P equal to 2. This is not to be counted. Okay, and how many zeros are inside? 1, 2, 3. How many zeros inside? Okay, these poles not to be counted. This zero not to be counted. Poles and zeros only inside. Only inside. Okay, so as per it, it is equal to P minus Z, and that is equal to 2 minus 3. N equal to -1. Okay, that is 1 clockwise. N equal to -1. Minus means clockwise. So how many encirclements of origin? How many encirclement of origin? Okay, once in the clockwise direction. How many encirclement of origin? Once in the clockwise direction. It encircles the origin once in the clockwise direction. Okay, once in the clockwise direction. Okay, once in the clockwise direction. It encircles the origin of GS plane once in the clockwise direction. Once in the clockwise direction. Okay, dear. It encircles the origin once in the clockwise direction. Okay. Right. So this is what about the number of encirclements. Okay, when you draw the GS plot. See, here we don't need to draw the GS plot. But when we are going to draw the GS plot. Okay, when this closed contour is mapped into the GS plane. Okay. Then that mapping, then that plot will encircle origin how many times? Without drawing the GS plot, we can solve by this formula. Okay. Solve by this formula. Okay. Okay. Now, let us come and use this concept to discuss the stability. Okay. Use this concept to discuss the stability of the closed systems, of the control systems. Okay. To discuss the stability of the control systems. Let us discuss the stability of the control systems, correct? Okay. For stability of control system, what is important? Okay. For stability of control system, what is important? The roots of characteristic equation, as I mentioned earlier also, characteristic equation. Okay, 1 plus GSHS equal to 0. The roots of it must not lie in the RHP or vice versa. If there is any root of characteristic equation in the RHP, system is unstable. Okay. If any root of the characteristic equation, if any root of characteristic equation is in the RHP, system is unstable. Right or wrong? System is unstable. So I have a search area. Okay, what is that search area? We need to search, okay, for the roots of this characteristic equation. Where? In the RHP. We need to search for the roots of this characteristic equation in RHP. What I do, I now take again a closed path in the S-plane. Let me define this Nyquist contour. Okay, which will describe Nyquist contour, or also known as Nyquist contour, also known as Nyquist path, also known as the Nyquist path. Okay, which is the closed path. Okay, which is the closed path. Okay, in the S plane. This closed path, again I'm mentioning, this closed path may be clockwise or anti-clockwise. Okay, right now I have again taken clockwise. Okay, what type of closed path? Okay, what type of closed path? Now, whether clockwise or anti-clockwise, both the differences we will see. We will take a closed path in S plane. Okay, to cover the entire right half plane, because I told you I have a search area. I need to search for the roots of characteristic equation in RHP. So I now take a closed path in the S plane to cover entire RHP, where again I am telling you that this closed path may be clockwise or anti-clockwise. Anyways, I can be taken. Here I have taken clockwise. Here I have taken the clockwise Nyquist contour, Nyquist path. How the Nyquist path is to be taken? Some closed path in the S plane to cover the entire RHP. So what I do? I start from a point just above the origin, this plus J0. Why do I avoid this origin? See, why do I avoid the origin? There is a simple logic. Okay, what can happen is, suppose dear GSHS. Okay, for the values of S in the S plane, we draw the GSHS values in the GSHS plane. Suppose you have some GSHS like this, 2 upon S, S plus 1, for example. Okay, if you take S equal to 0, what is GSHS? Undefined. GSHS becomes undefined, infinity. Okay, the value of the GSHS is undefined, and hence you can't plot this particular point. Okay, so very commonly in many of the GSHS, S equal to 0 is a pole. And if S equal to 0 is a pole, if you calculate the value of GSHS at S equal to 0, that value of GSHS becomes undefined. So normally what we do is, when we are considering the Nyquist path, okay, we avoid the origin. That means I start just above the origin. This plus J0, okay, this plus J0 is just like, okay, it is just like limit S tending to 0 plus. It is just like limit S tending to 0 plus. Okay, limit S tending to 0 plus, and this 0 minus is mathematically just like limit S tending to 0 minus, just above 0 and just below 0. Okay, so I start from a point just above the 0. Okay, running along the y-axis, I reach to the top, that is plus infinity, plus J infinity. Okay, so let me describe it. Okay, from S equal to J0, okay, or S equal to plus J0, I go to plus J infinity. Okay, along the y-axis. Then from the plus J infinity, taking a semicircular arc of infinite radius. Okay, a semicircular arc of infinite radius. Taking a semicircular arc of infinite radius, I reach to minus J infinity. Okay, a semicircular arc of infinite radius. What is the meaning of infinite radius? That means if I take the infinite radius arc, I'm covering all the points of the right side. I'm covering all the points of the right half plane, correct? I am covering all the points of the right half plane. Is it clear? I am just covering all the points of the right half plane. Done? I am covering all the points of the right half plane. Okay, I reach minus J infinity. Okay, after reaching minus J infinity, again I start traveling up along the y-axis to reach minus J0. Okay, and then from minus J0, I need to come back to the J0. Now, I am telling you exact origin is avoided for the region I told you. Okay, how do we join minus 0 to plus 0? I'll take it separately. I'll explain you this small arc. Okay, because this is a very small arc, just below the origin to just above the origin. Okay, so we'll take it separately. Okay, so right now this is what is my Nyquist path. Some closed path in the S plane to cover up the entire RHP. Okay, and to cover up the entire RHP, I first start, okay, moving along the y-axis. Okay, taking a semicircular arc of infinite radius, coming back to the negative y-axis. This is minus J infinity. Okay, from minus J infinity reaching the minus J0, and later on I will show you how do we close from minus J0 to plus J0. This is some clockwise Nyquist contour. This is some clockwise Nyquist contour. Clear? Okay, some clockwise Nyquist contour. What we do, like, okay, some closed path we have taken earlier in the S-plane, corresponding to the value of S in the closed path shown, we draw the value of GSHS. Where do we draw the value of GSHS? In the GSHS plane. Okay, similarly, for the values of S now shown to you, again some S-plane and GSHS plane picture has to come. For the value of S now shown, if you take such values of S, to cover entire RHP, for these values of S, when you draw the GSHS plot, such a plot will be then known as the Nyquist plot. For the closed path which is shown above, shown in the previous picture, what closed path was shown above? That is the Nyquist path. Nyquist path or Nyquist contour. The values of GSHS are plotted in the GSHS plane, and the plot then obtained is known as the GSHS plot. The plot then obtained is known as the GSHS plot. Okay. From that GSHS plot, which is now known as Nyquist plot, from that Nyquist plot, the number of encirclements of origin, how many times the Nyquist plot, when we draw, how many times the Nyquist plot is rotating around the origin. Okay, as I told you in the beginning, sketching Nyquist plot is a different point. Okay, we should also know the techniques of quickly sketching Nyquist plot. Okay, but firstly, what I am covering right now is the stability criteria, the concept of Nyquist. Because many questions, especially recent 5-10 years, it is not about Nyquist sketching. It is about analysis of Nyquist plot. So that concept is very important. All these encirclement, when to use n equal to p minus z, I have shown you two cases. Okay, p minus z, z minus p, all this is very, very important. Okay, especially for the recent trend of the question. Okay. Right, plotting also we can learn separately. So suppose I know how to draw the Nyquist plot. I have done some Nyquist plot sketching. Okay, from that Nyquist plot, the number of encirclements of the origin will be observed, and it is given by the formula n equal to p minus z. Okay, same formula n equal to p minus z, because the Nyquist contour that I have taken right now is clockwise. Okay, this is the formula for the Nyquist clockwise Nyquist path. Okay. Again, if it is anti-clockwise path, Nyquist path, the formula will become z minus p. Now in this formula, very clearly I write p plus and z plus. Okay, to make you remember easily, I write p plus and z plus, because in our original formula, p minus z, what is p and what is z? It is the poles and zeros of GSHS which are inside the closed path, not the total poles and zeros of GSHS. Only the poles and zeros of GSHS which are inside the closed path. Okay. Now, what is my closed path right now? Right now, my closed path is such a path which covers the entire RHP. So, what P and Z I am talking about? P and Z are the poles and zeros inside this closed path. Okay. That means P and Z are any poles and zeros in the right half plane, in the positive area, in the right side area and the positive area. Okay, so I call it as p plus and z plus. So have a look into this definition with me. What is p plus? Poles of GSHS in the RHP. Actually inside the closed path, which is RHP here. Similarly, what is z plus? Zeros of GSHS inside the closed path. P and z, poles and zeros inside the closed path. What is the closed path right now? Right now, closed path is such a path which covers the entire RHP. Okay, so I say P plus is the poles in the RHP, Z plus is the number of zeros of GSHS in the RHP. RHP means right side area, positive area. So to make you remember easily, I use this plus and plus, P plus and Z plus, the poles and zeros in the positive side, right side. Okay, right. So I don't want total poles and zeros of GSHS, only poles and zeros of GSHS which are in the RHP, and N is given by P plus minus Z plus, right? Suppose you draw the Nyquist plot. Now come to the next very important point. Suppose you draw the Nyquist plot. I'm telling you, sketching Nyquist plot again is a different art. Okay, that we'll cover later. Okay, but suppose you draw the Nyquist plot. Okay, once you draw the Nyquist plot, then you can observe. Okay, suppose some Nyquist plot, some GSHS plot you have drawn like this. Okay. Once you have drawn any GSHS plot, then you can observe how many times you are moving around origin. How many times origin is encircled. That is what is n value here. So once you draw the Nyquist plot, Okay, you can notice the n value. Suppose p plus I give you, somehow p plus I give you. Okay, somehow suppose p plus I give you. Okay, so p plus is known to you. Then you can calculate the value of z plus. Then you can calculate the value of z plus. Then you can calculate the value of the z plus. Clear? Okay, what is z plus? Zeros of GSHS in the RHP. But students, we need to talk about stability of control systems. Okay, we need to talk about stability of control systems. And for stability, what we need? Okay, for stability, we need roots. Okay, or let me put it this way, roots or zeros of which equation? For stability, we need the roots of characteristic equation. What is the characteristic equation? 1 plus GSHS equal to 0. So you need the zeros of 1 plus GSHS. Zeros of 1 plus GSHS means the points. Zeros of any function means the point where the function is 0. So I am interested in the zeros of 1 plus GSHS, not the zeros of GSHS. Okay, this equation is giving me some information about zeros of GSHS, but for stability, we are not interested in zeros of GSHS. We are interested in the zeros of 1 plus GSHS. We are interested in zeros of 1 plus GSHS, correct? That is what will become our characteristic equation. Okay, that is what will become our characteristic equation. Okay, now that means some modification is to be done. Okay, what is that modification? What is that modification? Okay, so now there are two things. Okay, so what I am telling you, if you need the information about zeros of 1 plus GSHS, so better draw the 1 plus GSHS plot. Better draw the 1 plus GSHS plot. Okay, better you have to draw the 1 plus, you don't have to draw the GSHS plot. You should actually draw the 1 plus GSHS plot. Okay, or vice versa. Now suppose if you are drawing 1 plus GSHS plot, let me go back to the previous example. This is some GSHS plot we have drawn. No? Suppose for the same GSHS, if I ask you to draw 1 plus GSHS, 1 plus GSHS. So what will happen? Dear, rather than GSHS, if you want to draw 1 plus GSHS, so what will actually happen? At the end, all values will be 1 plus 1 plus 1 plus 1 plus. That is what you will do. No? You will add 1 to all the values. Okay, 3 plus 1 will become 4, minus 1 plus 1 will become 0. Here, real part. Plus 1 means only real part. So 1 plus minus 4 minus 3. 1 plus minus 4 minus 3. So what actually is going to happen, you know, dear? If you add 1, minus 1 plus 1, see here. Okay, minus 1 plus 1, 0. Okay, minus 4I plus 1. Plus 1 means only real part. Okay, real part you will come to minus 3, no change in imaginary part. Okay, again minus 4I, so minus 4 plus 1, minus 3, only real part. No change in the height, only change in the x direction. And 3 plus 1, 4. Okay, all the values are added plus 1. So all the real parts are incremented by 1. So entire plot will move along the real axis by 1 unit. See, I'll show you that plot. Let me join these points. Okay, this is my first point, second point. Okay, third point, fourth point, back to the first point. Now when you compare both, see the pictures are in front of you. When you compare both of them, exact same shape. What is the only difference? Okay, the green one is the GSHS plot. The green one is the GSHS plot. This is the 1 plus GSHS plot. Okay. So dear, if you already know to draw GSHS plot, no need to draw 1 plus GSHS separately. It is just right shift the plot by 1 unit. It is just right shifting the plot by 1 unit. Clear? 1 plus GSHS plot means just right shifting the GSHS plot by 1 unit. Okay, right shifting the GSHS plot by 1 unit. Okay, 1 unit forward, 1 unit along the real axis, or vice versa. Vice versa. Why to shift the plot? Plotting is done. Plotting takes effort. Plotting is done. We have drawn some GSHS plot. Why to shift the plot? Let's do some reverse phenomena. Okay, rather than shifting the plot to the right, I will shift this imaginary axis to the left. I will actually shift this imaginary axis to the left. Okay, one and the same thing, na? Rather than either you shift the plot to the right or bring the origin to the left, bring the imaginary axis to the left. Okay, if you bring the imaginary axis to the left, 1 unit left, this becomes your new origin. What is origin of any coordinate axis? Where x and y axis intersect. What is origin? Intersection of the x and y axis. So since you are shifting it 1 unit left, where is the origin now? Where is the origin, which is 0, 0, now becomes minus 1, 0. The origin which is supposed to be 0, 0 will now become minus 1, 0. Okay. So what I was telling you is, we are interested in the zeros of 1 plus GSHS. Okay, that means you draw the 1 plus GSHS plot. Okay, now to draw the 1 plus GSHS plot, okay, there are two things. Okay, shift the GSHS plot, because you are adding plus 1, adding a real part. So shift the GSHS plot by 1 unit right, or reverse effect, shift the origin by 1 unit left, and hence we get, okay, draw the GSHS plot only. Don't shift the plot, draw GSHS plot, just assume a new origin. We call it as modified origin. Minus 1, 0. That is the reason whenever you might have studied Nyquist plot, we talk about the encirclement of minus 1, 0. That is the reason behind that. Okay, call it as a modified origin. Okay, now the formula which I told you, n equal to p plus minus z plus, I'm rewriting the formulas. n equal to p plus minus z plus, where n again means the same. Okay, n is the number of encirclements of origin, but which origin? Modified origin. Which origin? Modified origin, minus 1, 0 by the GSHS plot. P plus will mean the same, poles of GSHS in the RHP. Z plus will be the zeros of 1 plus GSHS in the RHP. Okay, why the meaning of P plus will never change? I'll tell you. Take a simple example. Why the meaning of P plus will not change? Okay, suppose I give you this function. Okay, suppose GSHS is s plus 2, simple example, upon s plus 3. Okay, what are the poles and zeros? Minus 2. And what are the zeros? Only one zeros. The pole is minus 3 and the zero is minus 2. Correct? Okay, if you talk about 1 plus GSHS, okay, 1 plus s plus 2 upon s plus 3. Even if you simplify here, even if you add here, denominator remains same. Denominator remains to be same. Okay, numerator will become s plus 3 plus s plus 2. Or it becomes 2s plus 5 upon s plus 3. Okay, so again, if you want to write down the poles, s equal to minus 3, and zeros will definitely change, minus 5 by 2. What is important is, the pole is same. The pole of GSHS or the pole of 1 plus GSHS. Actually, we are considering 1 plus GSHS plot, but we will not draw 1 plus GSHS plot. We will draw GSHS plot only. Okay, and shift the origin 1 unit left. Okay, so we will assume a modified origin minus 1, 0. Okay. So because we are talking in a way about 1 plus GSHS plot, we should talk about the poles and zeros of 1 plus GSHS. Here it is. Okay, what is Z plus? Zeros of 1 plus GSHS. What is pole? P plus, it is the poles of GSHS or poles of 1 plus GSHS, which is the same. The poles of GSHS or poles of 1 plus GSHS is one and the same thing. Okay, so that is why P plus I don't change. P plus is the poles of GSHS in the RHP. Z plus meaning will change. Z plus is the zeros of 1 plus GSHS in the RHP. And N will again be the encirclement of origin, but which origin to keep in mind? Minus 1, 0. Which origin to keep in mind is minus 1, 0. Okay. minus 1 comma 0, right? Okay, so Z plus is the number of zeros of 1 plus GSHS lying in the RHP, and N is the number of encirclements of the modified origin, okay, minus 1 comma 0 by the GSHS plot. Okay, P plus remains to be same. P plus remains to be same. Okay. Right. So the P plus, the poles of GSHS or poles of 1 plus GSHS remains to be same. Okay. They remain to be the same. Okay. Right. Now, one last calculation. As I told you, if I come back to the Nyquist path, okay, I told you origin is skipped for a reason, because, okay, if GSHS is example 2 upon S plus 1, and if you put S equal to 0, it may be a pole, and at S equal to 0, GSHS undefined. We cannot draw the GSHS plot there. That is why in the S plane, okay, for the closed path, origin is actually avoided. Okay, we take below origin, just below origin, and we take a point just above origin. Okay, and we join them, not exactly touching the origin. Now, how do we join them? What is the closing from minus 0 to plus 0? Okay. What is the closing from S equal to minus J0 to S equal to plus J0? Okay. S equal to minus J0 to S equal to plus J0. Okay. Just imagine this picture here. I'll make actually a little bit zoomed picture. I'll actually make a little bit zoomed picture. Okay. Suppose this is minus J0. Okay. It should be very close to origin, but just I am taking a zoomed picture for your visibility. And suppose this is plus J0. Okay. So minus J0 plus J0, little bit zoomed picture. Okay. Okay. But these are actually very, very close to origin. So when I go from minus J0 to plus J0, for this very, very small arc, actually I am taking anti-clockwise movement only, because we have to be in the RHP only, not in the LHP. Okay. Now take any point on this arc. Take any point on this arc, suppose S. Okay. And this S, let me call it as R e power j theta. R means the magnitude. What is the magnitude of any complex number? Distance from origin. And what is the phase or angle of any complex number? Okay, it is the angle of the line joining the complex number to the origin with the real axis. So this is the angle theta. Okay, this is the angle theta. Generally GSHS, okay, okay, can have multiple zeros terms, 1 plus ST1, 1 plus ST2, okay, divided by S power n, 1 plus STA, and some other multiple pole terms, 1 plus STA, 1 plus STB, etc. But since I am very, very close to origin, so what is the value of S I am taking? S tending to 0. Okay, as I told you earlier also, this is like S tending to 0 plus, and this is like S tending to 0 minus. So that means ultimately S tending to 0, left side to right side. Okay, so dear, if S is tending to 0, okay, 1 plus ST, 1 plus 0 will be 1. So what are the only terms that is going to be left? Limit S tending to 0, only some K upon S power n. Okay, this is the only thing that can trouble you, because if S is 0, denominator 0, the value of the function can be undefined. Okay, so now this is now equal to limit K upon S power n. If S is R e power j theta, R power n e power j n theta. Okay, R power n e power j n theta. S tending to 0 means R tending to 0, because this is the arc very, very close to origin. Okay, the radius of this arc will be 0. The distance from origin will be tending to 0. Limit R tending to 0. So this is equal to limit R tending to 0, K upon R power n, e power j n theta shifting above, e power minus j n theta. Okay, e power minus j n theta. Okay, so what is the magnitude part? Magnitude part is limit R is tending to 0, K upon R power n. Okay, because R is tending to 0, this will be tending to infinity. So the magnitude of GSHS around origin will be very large. But what about angle GSHS? E power minus j n theta. What is the angle part? Minus n theta. E power j theta, theta is the phase. Here it is e power minus j n theta, minus n theta is the phase. Okay, minus n theta is the phase, correct? Minus n theta is the phase, correct? Okay, so the face is actually minus n theta. Okay, now if the face is minus n theta, if I start with s equal to minus j0, what is the theta? Minus j0, what is this theta? When you come to this point here, this theta, okay, will be this direction. The theta will be 90 degree in the clockwise direction, minus 90. Theta equal to minus 90 minus pi by 2. So what is angle GSHS? Angle GSHS is minus n theta, minus minus plus, so this is n pi by 2. But if I take s equal to plus j0, what will be theta here? So if you take this point and take this much of the angle, so this becomes plus 90 degree, anti-clockwise 90 degree. So at this point, theta equal to plus pi by 2. Okay, what is angle GSHS? Okay, is minus n theta. Okay, and that becomes minus n pi by 2. So how much is the change in angle GSHS? How much is the change in angle GSHS? Final minus initial. Minus n pi by 2 minus of n pi by 2. Final minus initial, it becomes minus n pi. Okay, it becomes minus n pi, or we also call it as n pi clockwise. Okay. That means whenever s changes from minus j0 to plus j0, okay, the change in angle GSHS will be n pi. That means we need to join these points through an angle of n pi in the clockwise direction through an arc of infinite radius. Okay, through an arc of infinite radius, because the magnitude is infinity. Okay, all these calculations, okay, when questions will come, will more better explained. Okay. Now take one specific question here first. Take one specific question here. Okay, look into this. One fundamental question, starting with a very fundamental question. Okay, no equations in virtual calculator of GATE. No sign, no quadratic, no cubic, nothing. Question. The Nyquist plot for the open loop transfer function GS of a unity negative feedback system is shown in the figure. Correct? The Nyquist plot for the open loop transfer function GS, some Nyquist plot is shown to you. Some Nyquist plot is shown to you. The Nyquist plot of the open loop transfer function GS of a unity negative feedback system is shown. If GS has no pole in the right half of the S-plane, GS has no pole in the right half of the S-plane, what does it mean? Okay, because dear, to talk about stability, we need one formula. Okay, to talk about stability, you can be using Nyquist plot n equal to p plus minus z plus. Let us assume clockwise Nyquist contour. Okay, nothing is mentioned. Let us assume clockwise Nyquist contour for a moment. Okay, we need the formula n equal to p plus minus z plus. So everybody recall, what is p plus? Dear, what is that p plus? This final formula. Okay, p plus number of poles of GSHS in the RHP. Z plus is the number of zeros of 1 plus GSHS in the RHP. And n is the encirclement of which point? Modified origin. Minus 1 comma 0. Okay, so if I apply that point here, n equal to p plus minus z plus, GSHS has no pole in the right half of the S-plane. The poles of GSHS in the right half of the S-plane. The poles of GSHS in the right half of the S-plane is known as p plus, and the question clearly says that there is no pole of GSHS in the right half. That means p plus equal to 0. Okay, the p plus equal to 0. So what is n? N is equal to minus z plus. What is n, dear? N is equal to the minus z plus. Clear? Okay, now the number of, what is the question? The number of, okay, the roots of characteristic equation in RHP. Roots of characteristic equation in RHP means zeros of 1 plus GSHS in RHP. Zeros of 1 plus GSHS in RHP means Z plus. The question is talking about Z plus. What I now say is n equal to minus Z plus, or what can I say is Z plus equal to minus n. So if you want the Z plus, you can calculate n. What is n? Number of encirclements. Of which origin? Modified origin. I explained you why we modify the origin. What is the modified origin? Minus 1 comma 0. This is the modified origin. Okay, this is the important point, minus 1 comma 0. Now see the encirclements of this point. One encirclement very clearly in the clockwise direction by the inner loop. One more encirclement, but that is in the anti-clockwise direction by the outer loop. There are two loops around this. Okay, dear, there are two loops moving around this point. So if I talk about minus 1 comma 0, It is encircled by the Nyquist plot, but how? It is encircled once in the clockwise sense by inner loop. By the inner loop. See, once it is encircled by this inner loop, by this smaller loop, okay, in the clockwise sense, right? And once in the anti-clockwise sense by the outer loop. Sometimes encirclements will be there, but net encirclement 0. It is also encircled by the outer loop in the anti-clockwise sense. This is anti-clockwise, opposite of clock. Okay. Okay. So what is the value of n? Once in clockwise. Clockwise means -1. Once in anti-clockwise, and anti-clockwise means plus. So net encirclement is 0. Okay. And hence z plus is -n minus 0. So z plus is also 0. The answer to the question z plus is also 0. Option number A. Z plus is also 0. Option number A. Option number A. Okay, dear. Now let's come to another question. A very good question actually. I'll take this question now first. GATE 2017 2 marks. GATE 17 2 marks. Okay, IIT Roorkee. IIT Roorkee here. GATE 17 2 marks. Very good question. Okay. Right? Understand this question. A unity feedback control system is characterized by the open loop transfer function 10k s plus 2 upon sq plus 3s square plus 2. Okay, 10k s plus 2 upon sq plus 3s square plus 2. Correct. Okay, some GS is given. The Nyquist path and the corresponding Nyquist plot of GS are shown in the figure. Some Nyquist path is given. Now see, everybody see the Nyquist path. Here the Nyquist path is also passing through origin. It is also passing through origin. Why? Because GS has no pole at origin. No pole at origin means the risky point was if there is a pole at origin, s equal to 0, GSHS cannot be defined. So that is why we avoid origin. But here this function does not have a pole at origin. So for this we can take the Nyquist plot directly passing through origin also. No need to take -0 to +0. Okay. So Nyquist path is shown to you. Okay. And how the Nyquist path is shown? Okay. How the Nyquist path is shown? Very clearly you see it is a clockwise Nyquist path. It is a clockwise Nyquist path, and because it is the clockwise Nyquist path, what is the formula? N equal to P minus Z to be taken. Okay, N equal to P minus Z. If it is anti-clockwise, I told you Z minus P. Okay, anti-clockwise means Z minus P to be taken. Okay, anti-clockwise means Z minus P, as I mentioned there. Remember this. Okay, let me again go back to our stability definition. Yeah, here also let me mention. Here I mentioned, I think. Here also let me mention. Okay, that this is again using clockwise Nyquist path. This is very important, so let me again mention it. If it is anti-clockwise Nyquist path, again you will take N equal to Z minus P. N equal to what? Z minus P. N equal to what? Z minus P. Okay, now let us come back to the question. This is the question we are discussing right now. Because it is clockwise Nyquist path, I will take N equal to P minus Z. Okay, N equal to P minus Z, correct? Now see, the Nyquist path and the corresponding Nyquist plot is also shown. For 0 less than k less than 1, the number of poles of the closed loop transfer function, okay, that lie in the RH of the S-plane, right half of the S-plane. So what is the question asking me? Clearly, what is the question asking me? Okay, the poles of closed loop transfer function. Poles of the closed loop transfer function in RHP. What is the poles of closed loop transfer function? Equal to roots of characteristic equation in RHP. Okay, better let me write it here. What I need is, listen, what I need is, okay, the question is asking me poles of the closed loop transfer function in RHP. Poles of closed loop transfer function in RHP means roots of characteristic equation in RHP. Okay, what is the roots of characteristic equation in RHP? Z plus for me. Z plus for what encirclement? For -1, 0 encirclements. When you consider n as the encirclement of -1, 0. When you consider n as the encirclements of -1, 0. Correct? -1, 0. Okay. Roots of characteristic equation in RHP, which is Z plus. Clear? Which is Z plus. Okay. Now, dear, what is the formula that we apply? The formula is n equal to P plus minus Z plus. Which n? -1, 0 encirclement. Okay. So, see, dear, where is -1, 0? Very clearly mentioned that K, the magnitude of K is between 0 to 1. So, that means if K is less than 1, so minus K will come before, na? So -1 will be after it, because K less than 1. Okay, so this much magnitude is 1, this much magnitude is K. So 1 will be outside. So very clearly -1, 0 is outside. -1, 0 outside. And if it is outside, no encirclement. Number of encirclement, how many times Nyquist plot will move around it, but that point is outside the Nyquist plot. Okay, so no encirclement, 0. Okay, so 0 is equal to P plus minus Z plus. What is Z plus? Then Z plus. The question is about Z plus. So Z plus equal to P plus. Okay. What is the P plus? Dear, what is the P plus? Poles of GSHS in the RHP. Poles of GSHS. Okay. It is a cubic equation. I will tell you a shortcut for the question. But let us first complete the concept. First, I'll then tell you the shortcut. What is P plus? What is P plus? The poles of GSHS. The poles of GSHS in RHP. Okay. What is P plus equal to? Come here. What is the P plus equal to, dear? P plus means the poles of GSHS in RHP. Number of poles of GSHS in RHP. Okay. So what is GSHS given? What is the denominator of it? Poles we will be calculating from denominator only. The GSHS here means only GS, unity feedback. 10K S plus 2, some 10K S plus 2 upon S cube plus 2S square plus 3S square, sorry, plus 3S square plus 2. S cube plus 3S square plus 2. Okay. Poles means S cube plus 3S square plus 2 equal to 0. How do you solve it? There is no cubic calculator now, and even GATE 17, the Casio scientific calculators were disallowed from 2016 year. Only virtual calculator from 2016. So you can't solve cubic equation. Now also in GATE 2017 also. Okay. No cubic calculator with you. Okay. No cubic calculator with you. Okay. So two ways here. Method number 1. Okay, what you want, you don't want the exact value. What you only want the number of poles. Okay, that means number of roots of this equation in the RHP. Okay, so Routh-Hurwitz criteria. Okay, number 1 method is Routh-Hurwitz. Number 2 method. The Nyquist plot conceptual method. Okay, number 2 method is use n equal to, again use the formula n equal to P minus Z. Okay, n equal to P minus Z, where n will be 0, 0 encirclement. Use the 0, 0 encirclements. Use the 0, 0 encirclement. And whenever you are taking the 0, 0 encirclement, then what is the Z plus? Then the dear Z plus is the zeros of GSHS. Then the Z plus is the zeros of GSHS in the RHP. Now see, what is the zeros? What are the zeros of this function? S equal to minus 2. There is only one zero. Minus 2. How many in the RHP? How many in the RHP? Nothing. Okay, and how many encirclement of 0, 0? Nyquist plot is given. You can calculate any type of encirclement. This is 0, 0. This is 0, 0. One encirclement anticlockwise. One more encirclement anticlockwise. One encirclement anticlockwise, one more encirclement anticlockwise. Two anticlockwise encirclement. Two anticlockwise encirclement. Okay. So n is how much? 2 anticlockwise. Okay. So anticlockwise means plus. So plus 2 is P plus minus Z plus. 0 is at -2. How many 0 of GSHS in RHP? Nothing. So hence P plus equal to 2. Hence P plus equal to 2. Okay. Okay, so here Z plus is P plus and P plus equal to 2. The Z plus is also 2. The Z plus is also 2. Option number C. Z plus is also 2. I explained you this method to explain you the method through Nyquist plot. That concept must hit in the brain. Okay. And I have used 2 points here. N equal to P plus minus Z plus. First, I have used -1, 0 encirclement. And then very smartly, I have also used the 0, 0 encirclement. Okay. Very smartly, I have used the 0, 0 encirclement. Okay. Now forget everything. Okay. Entirely different approach. Okay. No Nyquist. Direct Routh-Hurwitz. No Nyquist, not even a single point of RH. Direct Routh-Hurwitz. Why? Why you can direct use Routh-Hurwitz? Because GSHS is given. Because GSHS is given. So we can form the characteristic equation. Dear, what is the characteristic equation? 1 plus GSHS. 1 plus 10k s plus 2 upon s cube plus 3s square plus 2. Like that, na? Yes. Okay. So that means s cube. What is the characteristic equation? I will write down here simplified characteristic equation. S cube plus 3s square plus 2 constant. So first let me write down this term. 10ks plus 10k into 2. 20k plus 2. 20k plus 2 equal to the 0. Equal to the 0. Clear? Okay. S cube s square. First two rows. 1 and 10k. 3 and 20k plus 2. S power 1. Cross multiply. 30k minus 20k. 10k minus 2. Is it 2? Are you sure? 10k plus 20k. I think that will not be 2. That will be 20. I think there is a typo error here. 3s square plus 20 it should be. Okay, no problem. Let's take it as 20 only. 100% this will be 20 only. Correct. Let me recheck it. 30k minus 20k minus 20 it has to be. Then only. Okay, yeah. So maybe a typo here. Let's say this is 3s square, s cube plus 3s square plus 20. Okay, s cube plus 3s square plus 20. No issues. Not 20, it should be actually not 20 also, it should be 10. It should be 10. It should be 10. It should be 10. Okay, it should be 10. No problem, there was a typo error I think in the PPT. Okay, let me make this as 10. Okay, so plus 20k and plus 10. Okay, so now see, cross multiply 30k minus 20k, that is 10k minus 10. Last element of a row 0, s power 0, x into 10 by x, so 20k plus 10. See what is given to you, 0 less than k less than 1. Okay, if k less than 1, 10k less than 10. If k less than 1, 10k less than 10. So this term 10k minus 10 will be negative. Okay. This is going to be negative. Okay. So what do you have? You have plus in the first row. Observing the sign in the first row. Okay. You have plus, then plus 2 minus sign change. And again minus 2. K is positive. Now 20k plus 10 is positive only. Again sign change. 2 sign changes. I have directly fed the characteristic equation. 2 sign changes in the first row. Okay. So 2 RHP roots of characteristic equation, and hence your answer is 2. Hence your answer is 2. This not at all using Nyquist. See, here I've just started the question from here. No Nyquist, direct Routh-Hurwitz. Smart approach. When GS is given and talking about stability, RH is there. In a very simple method, RH is always there. Okay. Actually, for such questions, Okay, GS should not be given. If you actually want to make it as a proper Nyquist question, then GS should not be given. Like in the previous question I solved, Nyquist plot is given. Where is GS? Whose Nyquist plot? That GS is not given. Only one information was given. GS has no pole in the right half of the S plane. Okay. So actually in such cases, okay, if Nyquist plot is given, GS, some information should be given, but not completely, because if GS is completely given, again like this question, if GS is completely given, you can solve it. You can solve it direct by RH. Yes, dear, you can solve it directly by the RH. No need for any other thing. Okay. Right. Now, dear, if this whole story is clear, we have used two cases, encirclement of 0, 0, -1, 0. Okay. So, what you are now going to do, try one question as homework. GATE 21, a very good question. Although 1 mark, but this is a good question of GATE 21. Okay, you have to try it as homework, and please mention the answer in the comment box, and I will update you in the comment box. I'll reply to your comments whether your answer is right or wrong. Read this question. And also, if you want a dedicated practice session, this was about the concept of Nyquist, how Nyquist stability criteria is developed. What is S plane? What is GSHS plane? What is the mapping from S plane to GSHS plane? What is that the formula n equal to p minus z or z minus p based on clockwise or anti-clockwise Nyquist contour? What is Nyquist contour? What is Nyquist plot? Why we talk about modified origin -1, 0 rather than 0, 0? All these points totally covered up with basic questions. Basic means some good questions actually. But if you want a dedicated more practice session for Nyquist plot, do mention in the comment box. I will plan for that. Okay. So if you want more practice around Nyquist plot, do mention in the comment box. I will plan those sessions as well for you. I will plan. But try this question as homework. Okay. Again, just you can take the screenshot. You can note down the question. And please do solve it up. It's a good question. It's a good question. Do mention me in the Telegram if you're not able to solve this question. I'll help you. I'll help you. Okay. I'll help you in the Telegram. Right. All right, guys. So whatever we discussed today, I will share you the PDF also. I'll share you the PDF. Okay. I'll share you the PDF, and the PDF will be available in this Telegram group. You can join using this link. Okay. The PDF will be password protected, and the password, simple password plot. We discussed Nyquist plot, stability using Nyquist plot. The password will be plot, PLOT. The password is going to be plot, PLOT. Simple password, everything in small. Okay. The PDF you will receive in this Telegram group, and that's going to be password protected. That's it from my side. This is Rakesh Talreja signing off. Bye-bye. Thank you. Stay safe. And do take care of yourself. Okay. Interesting. Maheshwari. Okay, you can mention the answer later also in the comment box, but Maheshwari has some answer. See, let me just check the number. What is the number in the C? Just recheck once, Maheshwari. I'll suggest you just recheck once, try once again and see the answer again. Just recheck it once, okay? Carefully. Okay, chalo. Bye-bye. Thank you. Good night. Stay safe and take care of yourself.